Let us discuss how to convert mole to mass using molar mass. Let us first have the definition for the law of conservation of mass. It states that mass can neither be created nor destroyed in a chemical reaction. Total masses of reactants is equal to the sum of masses of the products. So let's have sample problem number 1. Determine the mass of the reactants and products given the chemical equation. So we have sodium plus oxygen, then it will produce sodium oxide. Here we already have a balanced equation. We have 4 moles of sodium for every 1 mole of oxygen and 2 moles of sodium oxide. If you want to determine the number of mole in a chemical reaction, simply look at the coefficient. So we have 4 as a coefficient for sodium, and then 1 oxygen, and for sodium oxide we have 2. So it means that we have 4 moles of sodium for every 1 mole of oxygen to produce 2 moles of sodium oxide. So these are the steps. Step 1. Determine the mass of reactant A. Here, our reactant A is sodium. So we will use the molar mass of sodium, which is 23 grams per mole. Okay, from that, we have 4 moles of sodium. Then we will use the molar mass of sodium. And so we have 4 moles sodium times 23 grams. For every 23 grams of sodium, we have 1 mole. So just cancel the same unit, that is mole, and then another mole here. Then what will happen is you will multiply 4 with 23. So 4 times 23, we have 92 grams sodium. So the mass of reactant A, which is sodium, is 92 grams. Step 2. Determine the mass of reactant B, since we already have the value for reactant A. Using the molar mass of oxygen, which is 32 grams per mole. As we all know, the atomic weight of oxygen is 16. 16 times 2, that is 32. So it means that for every 1 mole of oxygen molecule, we have 32 grams. So 1 mole of oxygen, from the balance equation here, we only have 1 mole of oxygen. So 1 mole of oxygen times 32 grams oxygen for every 1 mole. Again, this is the molar mass for oxygen molecule. Just cancel the same unit, which is mole. And then that is 1 times 32. So the mass of reactant B is 32 grams. Then step 3 is, since we already know the mass of reactant A and reactant B, we will determine now the mass of the product using the molar mass of sodium oxide, 62 grams per mole. So how did we get 62 grams per mole? So this is a recall of determining the molar mass of a compound. So we have sodium oxide. Here we have 2 as a subscript for sodium, so we place 2 here. And then for oxygen, we only have 1. Now, we will refer to the periodic table and determine the atomic weight of each element in the compound. So, we will look for sodium. The atomic mass for sodium is 23, oxygen 16. Then just multiply 2 times 23, that is 46. 1 times 16, 16. So just add it, and then we have 62 grams per mole. That is how we get the molar mass of sodium oxide. Now, since we have the value for the molar mass of sodium oxide, then we can convert the given mole into mass. Still, we will use here 2 moles of sodium oxide. Then we will use the molar mass. So that is, first we'll have to cancel the same unit, and that is mole. So 2 times 62, we have 124 grams sodium oxide. Okay, so the mass of the product is 124 grams. So, arranging that in a tabular form, we have this. The chemical reaction is sodium plus oxygen, then the product is sodium oxide. So, the mass of reactant A in grams is 92, and the mass of reactant B in grams is 32. And then the mass of the product is 124 grams. So, following the law of conservation of mass, it states that the total mass of the reactant must be equal to the total mass of the product after the chemical equation. So, if we will add 92 and 32, the answer is still 124. So, 124 grams for the reactants and 124 grams for the product. So, it follows the law of conservation of mass. So, let's have another problem. Let's have sample problem number 2. Determine the mass of the reactants and products given the chemical equation. This time we have lithium sulfate plus barium nitride, and then it will produce lithium nitride and barium sulfate. Before you determine the mass of the reactant and product, the chemical equation should be balanced. So we have 2 atoms of lithium here on the reactant, and then on the product we only have 1 atom of lithium. So if you have 2 atoms of lithium on the reactant, on the product you need to have um 2 atoms of lithium also. So as you all know, to balance the chemical equation, you will place a coefficient. It is a number written before the chemical formula or chemical symbol in order to balance the chemical equation. So it is given here that we need to place coefficient 2 before the chemical formula of lithium nitride. So we will place 2 here. And then from that, 2 times 1, we already have 2 atoms of lithium on the product and 2 atoms of lithium on the reactant. And then for sulfate, this is a polyatomic ion. We have 1, okay, 1 set of sulfate, and then on the other side still 1 set of sulfate. And then barium, 1 only, on the product 1, nitrite 2, and then since we place 2 here, we also have 2 sets of nitrite. So the equation is already balanced. So it means that we can now determine the mass of the reactants and products given this balanced chemical equation. So always remember that before you determine the mass of the reactant and products, the equation must be balanced. Okay? So, in this equation, we have 1 mole of lithium sulfate that reacts with 1 mole of barium nitride and 2 moles of lithium nitride and 1 mole of barium sulfate. Okay? So, since the equation is already balanced, then we can determine the mass of reactant and product. Okay? Step 1. Determine the mass of reactant A. And our reactant A is lithium sulfate. So we have 110 grams per mole. So how did we get 110 grams per mole? Still, we will recall determining the molar mass of a compound. So in lithium sulfate, we have 2 atoms for lithium since the subscript for lithium is 2. And then sulfur, 1 atom only since we don't see a number here. And then oxygen, that is 4. Then you refer to the periodic table, look for the atomic weight of these elements. Okay? So the atomic weight for lithium is 7, sulfur 32, oxygen 16. 2 times 7, 14. 1 times 32, 32. 4 times 16, 64. Then add it all. That's why we have 110 grams per mole. Okay? Now, from the balance equation, we only have 1 mole of lithium sulfate here. Then using the molar mass, first you have to cancel the same unit. Same unit here is mole. So 1 times 110. So the mass of reactant A is 110 grams lithium sulfate. Step 2, determine the mass of reactant B. And our reactant B is barium nitride. Okay? And then we have 229 grams per mole. Still, how did we get 229 grams per mole? That is barium. 1 only since we don't see a number here. Nitrogen. Nitrogen here is enclosed in parentheses. We don't see a number. It means 1 times 2. That's why we have 2 atoms here. And then oxygen, we have subscript 2 inside. And then it is enclosed in parentheses. We have 2 here on the outside part of the parenthesis. So that is 2 times 2. That's why we have 4. Then we will use the atomic weight. Barium is 137, nitrogen is 14, oxygen is 16. So we'll just multiply each. So 1 times 37, no, 1 times 137, that is 137. 2 times 14, 28, and 4 times 16, 64. Just add it all. That's why we have 229 grams per mole. Then we can now convert mole into mass. We don't see a number here, so it means 1. We only have 1 mole of barium nitride. And then we will use the molar mass. Of course, we still have to cancel the same unit. We have mole here and mole. So the remaining unit will be grams. So 1 times 229, we have 229 grams barium nitrate. And that is the mass of our reactant B. Okay, step 3 is for us to determine the mass of product A. In this case, product A is lithium nitride. The molar mass is 53 grams per mole. So how did we get 53 grams per mole again? Lithium, we only have 1 atom here since we don't see a number. Nitrogen, 1 also. And then oxygen, 2. Now, refer to the periodic table again and look for the atomic weight of these elements. So, for lithium, 7, nitrogen, 14, and oxygen, 16. So, just multiply 1 times 7, 1 times 14, 2 times 16. So, that is 32. So, 7 plus 14 plus 32, and the answer is 53 grams per mole. After that, then we can solve for the mass of product A. We have 2 moles here from the balance equation. We have 2 here, so it means that we have 2 moles of lithium nitride. So 2 moles of lithium nitride times the molar mass of lithium nitride, which is 53. So cancel first the common unit, and that is mole. Then 2 times 53, we have 106 grams. Okay, so the mass of product A is 106 grams. Okay, so let's have the last part, step number 4. Determine the mass of product B. And our product B here is barium sulfate, and the molar mass of barium sulfate is 233 grams per mole. So barium, we only have 1 atom, sulfur, 1 atom also, and oxygen, 4 atoms. And then the atomic weight of barium is 137, sulfur 32, oxygen 16. So 1 times 137 is 137, 1 times 32, 32, and 4 times 16, 64. So if we will add it all, that will be 233 grams per mole. So now, since we already know the molar mass of barium sulfate, then we can convert the given mole, which is 1 only for barium sulfate, 1 mole of barium sulfate times 233. So the mass of product B is 233 grams. Okay, that's all. Thank you for watching.